Hi, my name's Chris Webb and I work on the Power BI Customer Advisory team at Microsoft. In this session, you'll learn how to tune the performance of dataset refreshes in Power BI. Now, before we start, I'm going to make the assumption that you want your datasets to refresh as fast as possible. That's a pretty obvious thing to want to have happen. You know, everybody wants everything as quickly as possible. And of course, nobody wants to wait around for their report to be ready. So I'll assume that you do want your dataset to be refreshing very quickly. But if it's not, what do you do? What are the steps you follow? In this presentation, I'm going to take you through at a very high level the steps that I follow for improving the performance of dataset refresh. We don't have time to go into complete detail about every single topic. I'd probably need 4 or 5 hours to do that, and you'd probably be pretty bored if you listened to me doing that. But at a high level, these are the steps you need to follow. First of all, as with a lot of performance topics, good performance starts from the very earliest design stages. So you're going to need to choose the appropriate storage mode for your use case, and you're going to need to model your data appropriately. You're also going to need to remove all the data that you don't need. Once you've done that, if you still find that refresh performance isn't what you want, there are a couple of things you'll need to tune. You're going to need to tune your data source, you're going to need to tune your Power Query queries, you're going to need to tune the analysis services engine, and then you're going to need to use tricks like incremental refresh and or data flows to be able to speed up refresh as well. And you're also going to need to remember that however refresh performs in Power BI Desktop, that may not be how refresh performs in production in the Power BI service. So you're going to need to test both of those. Okay, so at a high level, that's what we're going to cover. Let's start at the very beginning. So like I said, good performance starts from the very earliest stage of designing your dataset. And perhaps the very first decision you have to make when you're designing your dataset is to choose a storage mode. Now, as you probably know, there are a couple of different choices for storage modes for data in Power BI. You've got import mode, where you copy the data for your dataset into Power BI, so it's stored in Power BI's own in-memory database. This gives you the fastest query performance, but it means you've got to copy the data into Power BI, which means that you've got to do a refresh. There's push mode. We're not going to talk about push mode because push mode has got a lot of limitations and it's not used very frequently. And then of course there's direct query mode. With direct query mode, you don't copy the data into Power BI. The data stays in the data source. And when a report runs, Power BI goes and gets the data it needs for that report from the data source on demand. So for example, if you're using a data source like a relational database, then Power BI, when a report runs, goes and runs a bunch of SQL queries to get the data that it needs. The good thing about direct query is that you don't need to refresh, so there's no refresh performance problems, but query performance is always going to be a lot slower than import mode. Now, to cut a long story short, my recommendation and the official recommendation from Microsoft about choosing a storage mode is always use import mode unless you have a good reason not to. And the reason that we always say use import mode is because it gives you the fastest query performance, and fast performance for queries for your reports is going to be the most important thing across the whole of Power BI. Everybody wants their reports to run fast, and there is no point building a report if it's going to take minutes or even hours to show its data. So you're going to want to use import mode, but of course that means you've got to refresh your data, and that potentially can be slow. Now, the good thing about Power BI today is that you don't have to make that binary choice between import mode and direct query. You've got the ability to create composite models and use aggregations. And this allows you to mix and match import mode and direct query mode inside your dataset. So you can have some tables in import mode and some tables in direct query mode. So typically what people do is, if they don't have time or they're not even able to load all of the data that they need into an import mode table, they might take some of their tables, have them in import mode, some of their largest tables, keep those in direct query mode, but then also build aggregations on top of those direct query tables that mean that the queries that Power BI reports run can maybe hit those aggregated tables, get good performance, and only when people really need that detail level data, they need to use direct query mode. So the first thing to say then, to get good performance for refreshing, is really think about your storage mode. Use import mode when possible, but perhaps direct query mode for very large tables is going to be an option, because that'll just mean that you don't need to refresh those tables. You'll only need to refresh perhaps some dimension tables and some aggregation tables if you're using a composite model. Now, for the rest of this presentation, I'm going to assume you're using import mode, because indeed with import mode, that's when you're refreshing data, and that's when you might need to do some performance tuning. So to be able to understand how to improve the performance, to tune the performance of refresh in import mode, you need to understand at a very high level what happens during refresh in import mode. And what I've got here in this rather crude diagram is a representation of what happens. On the right hand side, we've got our data set. We want to refresh it. So when we click the refresh button, what happens? Our data set is composed of a number of different tables, and each of those tables is fed by one or more Power Query queries. So when the data set's refreshed, those Power Query queries are run. Now, those Power Query queries will, in most cases, connect to some external data source. So they'll be running queries or just fetching the data from that external data source, whether it's a relational database or a text file or whatever. And those data sources themselves may have to do some work to get the data. If you're running a SQL query against a relational database, then that SQL query might take some time to run. But eventually those data sources will return data back to the Power Query queries. The Power Query queries themselves may need to do some transformations, and that in itself will take a certain amount of time. And then when those Power Query queries are able to return data, they'll return the data back to the dataset. And indeed, there could be some other things, well, there will be some other things that need to happen here to take that raw data and build it into the in-memory structures that import mode uses, and build other things like relationships and maybe even calculated tables and calculated columns. So we've got three places where work is being done when you do a refresh in import mode, and therefore three places that we might need to do some tuning. The next important thing to be able to understand when you're trying to tune refresh performance is how long a refresh takes. Because if you're doing tuning and you make a change, you need to know whether that change has really improved performance or not. And therefore you need an accurate way of knowing how long a refresh takes. Now, there are a whole bunch of different tools that you can use for trying to understand refresh performance in Power BI. But at this level, the most important one is good old SQL Server Profiler. Because as we saw on the previous slide, when you're doing a refresh, you're basically kicking off a refresh inside your dataset. And when the dataset refreshes, that kicks off a whole bunch of other things. So the amount of time it takes to refresh the dataset is the important thing. That will include all of the times taken to refresh the Power Query queries, to get the data from the data source, and so on. And the dataset, the engine inside Power BI, is basically the analysis services engine. And SQL Server Profiler is a tool that allows you to connect to SQL Server Analysis Services and Azure Analysis Services to see what happens inside that engine when queries run or refresh takes place. And because Power BI includes a version of the Analysis Services engine, you can use Profiler to connect to Power BI and see what happens when a refresh takes place. It's a little bit convoluted to be able to connect Profiler up to Power BI Desktop when you're doing some performance tuning, but it's not all that difficult. The first thing to know is that you'll have to install an external tool called DAX Studio. Now, if you don't have DAX Studio, go away and Google for it. It is an amazing tool. It's something that you will need anyway when you're developing inside Power BI. But I've already got that installed. Here's my Power BI desktop file with all of my refresh demos in. Now, DAX Studio is a third-party community developed tool, but thanks to the new external tools functionality in Power BI Desktop, I can launch it directly from Power BI Desktop. I don't have to go anywhere else. So there's DAX Studio. Let's just launch it from here. And while DAX Studio allows you to do a lot of really cool things, it also allows you to launch Profiler with a connection already open to your Power BI Desktop instance. So I just need to go to Advanced, go to SQL Profiler, and this will in turn open up SQL Server Profiler. Now it's going to open it up with a connection to the Analysis Services engine running inside Power BI Desktop. But before I do anything else, I'm going to have to choose some events. So I need to go over to Event Selection. And there are tons and tons of different events that you can choose here. But the ones that I'm going to select for this analysis are Command Begin and End. Now, Command Begin and End are the events that are fired when a refresh starts and ends. They'll be fired in other cases as well, but as long as we're only refreshing in Power BI Desktop, that's pretty much the only time we'll see them. And I'm also going to go down here and choose the Progress Report Begin and End events as well. And this will give me a bit of detail about what actually happens inside the Analysis Services engine when refresh takes place. I'm also going to go here and organize the columns because the columns are not always in the order that I like. I'm going to put event subclass and event class up together up here. I'm going to find the duration column, and I'm also going to put it up close to the top. And finally, I'm going to find text data and put it all the way up to here. So I can click OK, click Run. Let's maximize this. And I'm going to go back to Power BI Desktop. I can either click the refresh button up here, some stuff will happen, or if I want to refresh an individual table, I can right click on that table and click refresh. So let's just click the refresh button. Some tables will be refreshed here. Don't worry too much about which tables are going to be refreshed right now. Some stuff happens. And in a moment we will be finished. And let's go to Profiler. Now you can see there are a number of different command begin and end events that have been generated here because, well, various other different operations take place when a refresh takes place. But if we go up to the top here, you'll see that there is one command begin event that has a whole load of stuff happening after it. And if we look in the contents of the text data column, which is displayed in the pane down here, this is going to be a refresh. You'll be able to see, looking down here, that this is a refresh from the various from here. So this is the refresh. There's a whole load of stuff going on inside here, and I'm going to scroll down. There will be a command end event associated with it. It's going to be pretty easy to spot because it's going to be the one that has the highest duration, which is here. Oh, sorry, not this one. It's a bit further down. It's here. This is the end of the batch transaction for the refresh. And what I can see here from the duration column is that this whole refresh took 9.5 seconds. So this is by far the easiest way to measure the performance of a refresh in Power BI Desktop. You can also use Profiler to connect up to a Power BI Premium capacity via an XMLA endpoint, but unfortunately it's not possible to connect Profiler up to Power BI shared capacity. There are a few other things that you might want to use to check the performance of refresh in the Power BI service after you've published. If we go over to the browser here, in the settings pane for your dataset, of course, you've got a refresh history link, which will tell you the start and end time for your dataset refresh, and that will tell you to the nearest second how long refresh took. There is, in Power BI Premium capacity, a new refresh summary page, which gives you actually a lot more detail about the duration of each refresh, and also the average duration, the number of refreshes per day, and the outcome. So that's really useful. And then also, if you've got Power BI Premium capacity, don't forget about the Power BI Premium Capacity Metrics app, which will give you a lot of useful information about how long each dataset took to refresh. Okay, so we know how to measure refresh performance. The next thing we need to do is model our data appropriately. Now, good data modeling is important because it's important. It's probably one of the most important things you'll do. And again, it's important not only for refresh performance, but for query performance, for being able to write your calculations the right way, for getting the right data out of your report. Good modeling is super important. And the basic rule you've got to follow is always build a star schema. Now, I'm not saying that good data modeling is always going to make refresh performance faster, because that's not true. It could be that modeling your data appropriately makes refresh slower, because if you've got data that's in a pretty messy state, you need to do a lot of transformations to get it into the form of a star schema. But generally speaking, good modeling is also good for refresh performance. There are a lot of mistakes that people make, I think, with their data modeling. For example, something I see is that people like to bring in tables with lots and lots of columns, very wide tables. Certain other BI tools that I won't mention really need all of their data into one gigantic big table, and some people think, well, the same applies for Power BI. That's not true. Other mistakes that I see people make are using expensive or incorrect data types. For example, if you've got money values inside a table, people use the double data type instead of the currency data type. And I also see people just bringing in multiple columns that could be unpivoted into measures. But let's do a demo. Now we know how to measure the refresh performance of a data set. Let's do a demo and see how good data modeling can make refresh performance better. Let's go back over to Power BI Desktop and let's open up the query editor. So if we scroll up to the top here, I've got 3 tables that I'm loading from CSV files. Now, in fact, this data comes from SQL Server. It's data from the AdventureWorks DW sample database, but I've dumped it to a CSV file just to try and get more consistent performance. I've got a fact table called Fact Internet Sales, and I've got 2 dimension tables, lookup tables called dim date and dim customer. I've also got what some people try to do, which is a single combined table with all of the data from dim customer, dim date, and fact internet sales. So no separate dimension and fact tables, everything all munched together into one big table. So let's see what performance is like. The first thing to say is that out of all of the tables I've got here in the Power Query editor, these 3 tables here that I want to test, dim customer, dim date, and fact internet sales, are the only ones that have got this enable load option checked. So that means that when I click the refresh button in Power BI Desktop, they're going to be the ones that are actually refreshed. This one, when I test it, I'm going to have to refresh separately. So let's close the Power Query editor. Let's clear what we've got in Profiler. I'm going to click refresh, and those 3 tables, dim customer, dim date, fact internet sales, are going to be loaded from CSV files. So you can see it takes a few seconds, but it's done. Let's go to Profiler, let's scroll all the way down, and you can see that the process, the refresh command here, took 6.6 seconds thereabout. There's the event, there's the duration column, that's 6.6 seconds. So loading all of these 3 tables separately from 3 different files took that. Now let's go over here and refresh that combined table. So only 1 table to refresh, exactly the same data, but all munched together into one big table. Now let's refresh. This is all coming from a CSV file, so it's all already been joined and merged together. The only difference is whether we've just got one big table with all of the data joined together already. You can probably already see that it's taking a little bit more time, but it's done. It's the same number of rows. Let's go to here. Let's scroll all the way down. And this, in fact, took 14 seconds. So, clear difference. Loading separate files is faster than loading one great big table all munched together. So, model your data as a star schema. It's always a good thing. Now, the next thing to think about is after you've modeled your data appropriately, think about only loading the data you need. It stands to reason that the more data you load, the slower your refresh is going to be. So there are a couple of things to think about. First of all, remove any columns in any tables that aren't needed for your report. Quite often when you're modeling your data, you'll see some data that looks like it's potentially useful. You might not need it for the reports you're building, but you think, oh, I'll just bring it in anyway. That's actually quite a dangerous thing to do. Because if you just bring in all of the data in your data source, well, that's going to increase your refresh times. And more than that, it's actually really difficult to remove those columns once you've loaded them in. Because if you've published a data set and you've built reports on top of that data set, and maybe other people have built reports on top of that data set, you can't actually tell easily whether any of those columns of data that you've imported are being used in any of these reports. So the best thing to do is just remove any columns you don't think you need or you know you don't need. Because it's actually quite easy to go back and add them in later on if you do find you need them. And because of the way that compression works in the Power BI engine, it's actually more important to remove columns than anything else. That's the best way of reducing the overall size of a data set and therefore reducing your refresh time. because the Power BI engine uses a column store database. Now, that doesn't mean that it isn't also important to filter out rows you don't need. For example, you might want to apply a limit on the amount of historic data that you load in, maybe only loading in 1 or 2 years of data. It's also worth bearing in mind that using deployment pipelines in Power BI Premium can be really useful if you want to limit the amount of data you work with in a development environment. Because when you're developing, you want to refresh as quickly as possible. So with deployment pipelines, what you're able to do is, in development, just work with a small subset of data, and then when you go to your dev or test environment, you can automatically change the data source or change a parameter in the Power Query queries that are used to feed your data set, and say, okay, well, now I want to use the full data set. Now, the type of data source that you're using when you're refreshing can also have a big impact on performance, because different types of data source will perform differently. A couple of general tips. Relational databases like SQL Server will pretty much always give you the best performance. They're able to get data and large amounts of data into Power BI as quickly as possible. And relational databases will always perform better than something like a text file. Even in the world of text files, there are going to be some big differences. CSV files will generally perform the best. They'll perform better than JSON files or XML files, and perhaps the slowest possible data source you can use for Power BI are Excel files. So think very carefully before you use Excel files, and if possible, try and use a CSV file instead of an Excel file. Something else you'll notice that web services can be very slow. And if you're working with files, file stores in SharePoint can be very slow to load compared to local files. So the upshot is different data source types perform differently. And it may be better to load your data into a fast data source like a relational database before it goes into Power BI, because it could actually save you some time to copy the data into another data source which can load that data quickly into Power BI rather than connect to a really slow data source directly. It's also worth pointing out that things like relational databases have got a lot more tools available to help you understand how long it takes to run the queries to get the data for Power BI. Something like SQL Server has, of course, extended events, SQL Server Profiler, lots of really cool things that you can use or your DBA friends can use to try and improve the performance of the queries that Power BI generates to get its data. And of course, if you're connecting to other data sources, you'll probably have less options. If you're connecting to a web service, tools like Fiddler can help you view the requests that Power BI makes to that web service. If you're getting data from files, I can highly recommend the tool Process Monitor from sysinternals. It allows you to see how much data and how long that data takes to be read from a text file. And there's another tool that we'll see in a moment, Power Query Diagnostics, that can also give you some useful insights when you're working with web services and text files as well. Another related matter is the location of your data source. Because if you're working with large amounts of data and transferring large amounts of data from a data source over to Power BI, that has to go over a network. And if you're moving a large amount of data a long way, then network latency is going to play a part. So think about where your data source is relative to Power BI, whether that's your Power BI desktop development machine or the Power BI service. And if you're going through an on-premises data gateway, think about the location of the gateway as well. Always try and put it as close as possible to your data source. Also bear in mind that if you're using Power BI Premium has a feature called multi-geo that allows you to locate different premium capacities in different Azure regions. And so it could be really important if you've got users all around the world to create Power BI Premium capacities all around the world, and make sure those premium capacities are not only close to the end users, but also close to the data sources that those end users expect to use. So we've thought about trying to improve the performance of our data sources. The next thing we need to look at is improving the performance of the Power Query engine. Now, the Power Query engine could be running in a number of different places. So we need to think about all of these different places separately. The first thing to think about when you're thinking about the tuning of the Power Query engine is the Power Query engine in Power BI Desktop when you're developing. Now, there are actually two ways that you can see the performance of your Power Query queries when you're doing a refresh in Power BI Desktop. You can actually see the performance, or at least you can see how quickly the Power Query engine can supply data to the analysis services engine using, again, SQL Server Profiler. So let's have a quick look here. Let's flip over to Profiler again. And here's the last test that we ran loading that large CSV file. If you scroll up right to the beginning of the Profiler trace, there are two events that you need to look at which will both together give you some idea of how quickly the Power Query engine is providing data to Power BI. The first one is this one. So you've got to look for a progress end event, which has got an execute SQL subclass. You can see in the text data there is an M query, and this duration here effectively tells you how long the query took before it said it finished executing. And if you click on here, you can see there's some M. It's not the M in your query, but it will tell you the name of the M query that it's executing here, combined customer internet sales date. Now there's another event you need to look at, because after the query is finished, it could still be sending data to Power BI, and this read data event is triggered when the analysis services engine finishes reading the data that's been provided by the Power Query engine. Now, sometimes one of these events is going to return, it's going to be very quick, and the other one will give you the true amount of time, but it really depends on the nature of the query, whether the query can start returning data before it finishes, or whether the query has to be executed completely before it can start even returning data. So you've got to look at both of these events. And in this case, you can see that actually the queries themselves were taking quite a long time to return data back to the analysis services engine. Another important tool you've got to use to see the performance of your queries in Power BI Desktop is the query diagnostics functionality. So you go to the Power Query editor and you go to tools, you will see that there are a number of different options here for diagnostics. First thing you're going to need to do is click on this diagnostic options button. This just opens up the options dialog, and you can see here some options for what data you bring back. Now I've just opted to make sure I get back detailed diagnostics. That's going to give you the most information. And there are some additional options here that will bring back performance counters for particularly long-running queries and data privacy partitions when data privacy rules are being enforced. Even if you select these options, you may not get this information. I've also got the option to enable diagnostics in the report and the query editor. In some cases, this is only going to be possible if you're running as an admin. If you're not, you can still enable diagnostics in the Power Query editor. Now, there is this option to diagnose step to do some diagnostics on an individual step in the Power Query editor. I generally don't use this because the queries you see here in the Power Query editor are not really a true reflection of what happens when you do a refresh. Because here in the Power Query editor, the Power Query engine is going to say, well, this is only a preview. Let's only have a look at the top 1,000 rows of the data source. So yeah, that can be a little bit misleading. What I prefer to do is when I want to test the performance of an individual query is start diagnostics, go to the main Power BI screen, click on refresh for the table associated with that query. It will load its data. We can go back up to the Power Query editor when it's finished. Click stop. And what we've got here are two new Power Query queries which read some log data that's been stored, and these will give you a lot of detailed information about what happened inside the Power Query engine when that query ran for that particular refresh. Now, this can be really hard to make sense of because it's really detailed information. And I've spent a long time trying to study this, and you know, I've come to the conclusion that the data as it's presented, it's great, it's detailed, but it's not always the easiest to interpret. So what I can say is have a look at two blog posts that I wrote back in February 2020. And these blog posts contain some more examples of Power Query queries that can take the data that's generated by diagnostics and prepare it in a way that makes it easier to analyze. The first one here is a Power Query query that restructures the data so it can be easily interpreted in the Power BI decomposition tree visual. So I've got a query here that does that takes data from a diagnostics trace that I ran some time ago, and you can see here I can break down that data using a decomp tree and see how long something took. I've also got another blog post here that, rather than prepare it for visual analysis, aggregates it up in a way that makes it easy to see how long each individual query took and then break down that particular query. And I've got an example of that here, where I've called my, here's the query that I'm getting. And in fact, what I need to do is this. And for the query that I ran earlier, I've in fact got two individual executions. We'll come to that later. But it's all been aggregated up so that I can go over to here. I can see a duration for the entire refresh, and I can then click on this child operations table here to drill down, see the child operations for that refresh, drill down a little bit more and explore the data that way. But for more details, this is quite detailed stuff, have a look at my blog posts from February. Generally speaking, I find that Profiler is probably a lot easier to use than Query Diagnostics. You've got to really know what you're doing with Power Query to get use out of Power Query Query Diagnostics. There are a few other massively important things that you need to do to improve performance of the Power Query engine in Power BI Desktop. First of all, you need to disable load of queries that you don't want to load in. You know, a really common beginner's mistake is that you connect to a whole bunch of data in the Power Query editor, and then you do other things in Power Query to combine these tables, these queries together to create, you know, tables with merges and appends. But then the source queries also get loaded into Power BI. And if you're loading in tables of data that you don't even need, that are just kind of means to an end to the data that you do need, that's going to take up a lot of space in memory, and it's going to take up a lot of refresh time. So the most important thing you need to do is to look at the queries that you don't want loaded into Power BI, right click and deselect the enable load option. Having done that, you can see the query name gets put in italics, and you can see that that's going to be a query that doesn't get loaded into the dataset. So make sure you do that. That's the number one most important thing. There are also a couple of options that you might want to play around with in the options dialog that can be really important. So if we go back to the main Power BI window, you go to File, Options and Settings, Options, and when the dialog appears, here we go. You can go to Current File, Data Load. So what are the ones that we want to look at? These three can be really important. First of all, auto date time will automatically, if you leave this option checked, automatically create hidden date tables for every single date column in your dataset. If you're anything like an experienced Power BI developer, you will always turn this off because you don't want those automatically created date tables. You want to use the date table that you've built. So always turn that off. It'll stop those automatic date tables being built. It'll reduce the size of your model, and it'll make refresh a little bit faster. More importantly, and I would say this is like a massively important tip if you're working with really complex queries, disable this allow data preview to download in the background option. Now, what does this do? If you think about what you see in the Power Query editor when you're working, you see previews of the data that's being returned by your queries. And indeed, if you click on individual steps, you'll see a preview of the data returned by each step. Now, in Power BI Desktop, and only in Power BI Desktop, when you do a refresh, those data previews also get refreshed. So if you've got lots of complex queries with complex transformations and lots of steps in them, when you do a refresh in Power BI Desktop, it's not only the data that gets loaded into your dataset, a whole bunch of other stuff is going to happen inside Power Query to refresh all of those previews that you see in the Power Query editor. And I've seen cases where the actual refresh only takes 30 seconds, but it can take anything up to an hour to build those data previews in the Power Query editor. Now, that's a really extreme case. But if you are doing lots of complex work in the Power Query editor, I strongly recommend that you have a look at disabling this allow data preview to download in the background option. What this will do is stop you seeing those previews, and they can be really helpful during development. You'll also see some kind of yellow warnings saying, oh, well, hold on, the preview has been cancelled, but ignore those and enjoy the performance benefits. Another thing that you might want to play around with is this option to enable parallel loading of tables. And this simply just says, when we're executing a refresh and we're refreshing the tables inside our dataset, do we want to refresh them all in parallel or in sequence? Now, in most cases, the default of having parallel loading enabled is the right one, because this can massively increase refresh times because refresh takes place in parallel. However, it is also the case in some fairly obscure circumstances that disabling parallel loading can improve performance, because some data sources will deliberately throttle you if you're trying to get too much data too quickly. And also, in some cases, if you're getting data from the same data from the same data source and using that in multiple queries, if you disable parallel loading, some extra caching can kick in inside the Power Query engine, which means that data is only got from the data source once, and then that cached copy of the data can be reused. But that may only kick in if you don't load your tables in parallel. So just experiment with this option. One or two other things to mention. Something that you may see if you're looking in your data source to see what happens when a refresh takes place in desktop is that you may see that Power Query tries to get the data from a data source twice. Now, this is kind of deliberate because when a refresh takes place, the Power Query engine says, well, okay, here's the data that I'm returning. But the analysis services engine says, well, I need to know what the schema of the tables is that you're giving me. Now, when a refresh takes place in Power BI Desktop, the first thing that the Analysis Services Engine says is, okay, tell me the schema of the tables, and it does that by saying, well, let's run those queries, but apply that we need to get the data, but apply a filter so we get only 0 rows. So we just get the column headers, nothing else. Now, in a lot of cases, the Power Query Engine can handle that quite efficiently, but in some cases it can't. And so when the Analysis Services Engine says, well, just give me that table, but with only 0 rows, that means the Power Query Engine has to run the entire query and get all of the data, then throw it away. Now, after that's happened, the Analysis Services Engine says, well, now I've checked the schema, I'm going to go away and ask to get the full data, and that's going to be the second time that the query is refreshed. There isn't an easy way of stopping that happening, but there is a way, and it involves some really complex M code that I don't want to go into. But again, I've got a blog post on this topic, so have a Bing or use your favorite search engine to search for my name and table.view, and you'll see some examples of how you can modify your queries with custom M code to stop this multiple read happening. And this can, in some cases, halve the amount of time it takes to load the data in Power BI Desktop. But this only applies to Power BI Desktop. And then finally, another thing that only applies in Power BI Desktop is the include in report refresh option. If we go back to the Power Query Engine up here, you can see that we've got this option for a query to be included in report refresh. Now, this only makes a difference in Power BI Desktop, but basically when this box is checked, then when you press the refresh button in Power BI Desktop, that table will be included in the overall refresh. But if you don't check this box, then the table can still be loaded, but it has to be loaded manually by right-clicking. If you click the refresh button, it won't be included. Another really, really important thing to bear in mind with the Power Query Engine is query folding. Now, this is a fairly widely talked about subject, so I'm not going to go into very much detail about it. There are going to be whole presentations available by me and other people that talk about query folding in the Power Query Engine. But basically what query folding means is that when you build a query in Power Query, in some cases the Power Query Engine can take the transformations that you're building into your query and push them back to the data source. Now, this is only going to be possible with some data sources, like relational databases or analysis services or OData feeds, and it's only possible for some transformations. But when it happens, it can make a massive difference to performance, because it means that rather than loading a lot of raw data and then forcing the Power Query Engine to do the transformations, the Power Query Engine can say, well, I need to connect to this data source but do these transformations. Let's get the data source to do the transformations and only give us the result. Let's see an example of this. Here I've got a query that connects to a table in a SQL Server database. It's the dim date table in the EventureWorks DW database again. And all I'm doing in this query is removing some columns from the table and filtering so I only get the rows where the day name is Friday. Now, because this is a relational database and because I'm using transformations that do support query folding, then when I do the refresh, what's going to happen is that Power Query is going to construct a SQL query to only get the columns and only get the rows that I want, run that SQL query, and then bring back just the result. Now, in this case, I can see this query folding happening quite easily by right-clicking on the filtered rows step here and going to View Native Query. I can see the SQL query that's been generated here. Now, when that option is available, that tells you that query folding is taking place. But if it's grayed out, that does not mean that query folding is not taking place. It just means that the Power Query Engine isn't telling you. And this is where you might have to look in your data source or use query diagnostics to see exactly what's going on. But there are a couple of different things that you can do that can stop query folding. For example, what I've got here is added an index column to the table before I removed columns and filtered rows. In this case, view native query is grayed out, because to get these values, Power Query, at least not yet, can't generate a query to get these particular index values. Another thing that you can do to stop query folding happening is writing your own SQL query. And this is a massively common thing for people to do. If you use your own SQL query when you're connecting to a relational database and you subsequently do transformations, those transformations will not be folded back to the data source. So be very careful when you do that. Of course, if query folding is not taking place and you're doing lots of complex calculations, the Power Query engine is doing all of these transformations for you, and that can be quite slow sometimes. There are some things that you can do to improve performance of the Power Query engine. Again, writing your M code in different ways can make a big difference to performance, but that's a massively complicated topic. It might well come down to the performance of your desktop machine and the amount of RAM you've got available before you actually see a difference in performance. But be aware that certain transformations such as sorting, merging, pivoting or unpivoting require all the data for a data source to be loaded into RAM while that happens. And because the Power Query editor limits the amount of memory a single Power Query query can use to 256 meg of RAM, that can cause some real problems. I've seen lots of cases where people are working with large amounts of data and doing things like sorts. The data is tried to be loaded into memory, it breaks that 256 megabyte limit, and then you end up with lots and lots of paging. So that's not a great situation. Something else that's worth bearing in mind is that if you're working with data that needs to go through an on-premises data gateway, the Power Query engine will execute queries on the machine where the on-premises data gateway is located. So the performance of the machine that you run your gateway on can be really important for the performance of refresh. And if you want to see what's happening on the gateway, there is some performance logging you can turn on in the on the gateway, and there is also a Power BI template report you can use to analyze this log data. A few last things to say. As well as tuning the queries you've got, it's also worth thinking of using other functionality in Power BI that can also improve refresh performance. Perhaps one of the most important things you can do to improve refresh performance is to use data flows to control how much data you load. So data flows effectively allow you to run Power Query queries in the Power BI service and do complex transformations on data before it gets to the data set. Now, what are the benefits of using data flows? Well, first of all, if you're doing complex transformations and preparing data, and that data needs to go and be used inside multiple data sets, when you refresh those data sets, you run the risk of basically doing the same complex transformations twice and hitting your data source twice. If you use a data flow, however, you can access the data source once. If that's slow, you just get the data out just once. You can do those complex transformations once, and then multiple data sets can just read that pre-prepared data, and that will improve performance as well. Another advantage of data flows is that if you're working with different data sources and your different data sources have data ready at different times, you can use data flows to prepare the data when each data source is actually ready rather than when the last data source is ready. So that can also buy you quite a bit of time. A few other things to mention. Data privacy checks are off by default in data flows. turning off data privacy checks can improve the performance of the Power Query engine, but I've deliberately not recommended that in Power BI Desktop because you really need to know what you're doing here. With data flows, data privacy checks are off by default because there's less risk for data privacy leaks, and this in turn can result in better performance. And if you're working with data flows in Premium, certain features like the enhanced compute engine or properties that you can set, such as container size, or features such as computed entities, can also dramatically improve the performance of your Power Query queries compared to what they might be if you're running them inside the dataset. Something else to mention are the use of calculated columns and calculated tables. A lot of people love to use calculated columns inside Power BI. They can make it very easy to break down complicated calculations into easier chunks. But calculated columns and calculated tables are evaluated during refresh and they actually persist data in memory when refresh takes place. So the more you have, the slower refresh will be because these are things that need to be created at refresh time. So something to bear in mind is that you can improve refresh performance by not using them. And in some cases, you can just get away with not creating calculated columns by instead rewriting your DAX to use measures. And bizarrely, this might also help query performance. Another related question people often have is, should I create calculated tables using DAX? Or should I use Power Query to do the same thing? Or should I prepare the same thing in my data source? Generally speaking, what I would say is you should always try to do any transformations or preparation of data as early as possible. Do it in the data sources if possible. Do it in the Power Query engine if you can't do it in the data source. And only use a calculated table or a calculated column if you have to. Now, certain calculations will be faster if you do them in DAX. But generally speaking, I would avoid using calculated columns and especially calculated tables unless you really know what you're doing and you've got a good use for them. And then last of all, something to mention is incremental refresh. Incremental refresh is now available for everybody. It used to be just in Power BI Premium, but now it's available in Power BI Shared Capacity. And it's a way of only loading new data into your data set. And as a result, if you can set up your data set so that it only loads new data rather than all of the data all of the time, it stands to reason that this is also going to really improve refresh performance. Now, out of the box, it's only going to work well with relational databases, and in particular relational databases that tend to be well modeled as dimensional models, the kind of data that you get with a data warehouse. But again, if you're clever with your M code, you'll find there are going to be blogs and examples out there on the internet that show you how you can modify incremental refresh for use with web services or folders containing multiple files. So that can also really improve performance overall. And then the very last thing to say is that refresh in Power BI service might well be different from the refresh performance you get in desktop. So always not only test in desktop, but test your refresh performance in the Power BI service, because things are different there. The resources you've got available, the resources the Power BI service, the hardware the Power BI service runs on is going to be different from what you've got available on your desktop. It's also worth remembering that the Power BI service will only do a refresh when it thinks it's got the resources available, which is not always the time that you've scheduled it for. So refresh performance might be slow because the Power BI service doesn't think it's got the resources available. And it might also be slow, especially if you're running on Premium, if other people are doing lots of refreshes or running lots of queries at the same time. And of course, the Power BI service is in the cloud, and it could take longer to get the data up to the cloud or from whichever data source into the cloud than it does to get data into Power BI desktop. So you've got to test it. Of course, if you've got Power BI Premium and you might find that refresh is faster there, And that's because Power BI Premium has more dedicated resources available perhaps than Power BI Shared. You'll typically only see a big improvement on a P2 capacity or greater though. That brings me to the end of my presentation. Thanks for listening, and I hope you found something useful to improve the performance of your refreshes. Thanks a lot.